Hey everybody, today I will do another quick problem in trigonometry. I will be doing another basic problem using the law of sines, and then probably we'll do another problem using eventually law of cosines, right? So basically, but right now I just want to focus on the law of sine, how can you use it in different situations. So okay, so let's get started. Let's do a triangle here. Um, let's do okay. So let's make it. Remember, we had um, there is some different type of triangles, and I want to clarify some that I think I mentioned last time. I say that two angles have to be given. Well, not necessarily. What I meant is either two sides and one angle have to be given, or or two angles and one side have to be given. Okay, so I want to make it sure that it's clear with everybody, because that's basically create confusions and not the little thing that I want to do here is to confuse people, right? So this is not me. No, there's a lot of confusion in the world right now already. So okay, so again, this is Conservative Engineering Academy, and we every once in a while I mention the name of Jesus over here. So that's basically one of the things that really I want to make it sure that yeah. So okay, so let's get started. So let's do this. Let's make it here. A. Let's make it B, and let's make it C, and this is a small a, this is B, and this is C, right? But, right, in our case, let's say, for example, that you have an angle over here that is 40 degrees, right? 40 degrees, right? But then you have two angles, right? You have, let me just delete this one. Let's say that you have this that is 20, right? I'm sorry, two sides. Two sides. And this is 30, right? Okay, in this case, right, we are missing, in other words, two angles, right? And to have it two sides, which in this case, this is called side angle triangle, right? And then there is SAS, right? SAS is also side angle side, and also this can be angle side. So there's a few of them. Okay, but anyway, two sides are given and one angle is given, right? So let's get started, right? So let's say, for example, we want to find this angle, right? Using the law of sines. What can we do, right? So in this case, remember that we have one angle. And we're looking for a third angle, right? Okay, a second angle, right? So after we have the second angle, we find the third angle, right? Easy. Okay, in this case, we have what? In this case, let's say, for example, we have this, of course, that was given to us, right? We use that. We can use the one that says sine 40 degrees over what? Over 20, oops. Over 20 equal to what was given? Well, this was given, right? So V is given, the opposite of V is given, the opposite of C is not given. So we cannot find C right now, but we can find the angle V because the opposite of B was given, and that is equal to, what? And that is equal to, sine of capital V, right? Over what? Over 30. Okay. All right. Now, let's cross multiply those. And we get 30 sine of 40 equal to 20 sine of B. Right? Okay, I think we're clear on that, right? Our goal is to solve for this, for sine of B, right? Capital B. That's the angle that we're looking for. In order to do that, we can actually do the following. We can say, okay, let's divide it by 20 on both sides. Right? Then we get sine of B. Sine of B is equal to, if I do the math on that, it's going to be sine of 40 over 20. Okay, that is 0.964, right? It makes sense, right? If this number was greater than 1, then we should run into problems, but in this case, it makes sense. Now, what we can do, right? We can do is following. We take the inverse. So we can say that B is equal to the inverse sine of 0.964, right? And now this angle is simply what? Take the inverse of that. Right? So the inverse of that, for some reason, is giving me some issues. The inverse on that is going to be 0.964. 74 degrees, right? So in this case, it's 74.6. So 74.6 degrees. Okay? So now we can come over here and in this triangle right here, and we can say that this angle here is 74.6, right? So let me just undo that because it looked kind of. Okay, so 74.6, right? Now we can say that angle C, right? So now angle C is equal to 180 minus 40 minus 74.6, and angle C is equal to right, and then 65.2 degrees. So this is 65.42 degrees, right? So now we have all the angles, right? Oops. Okay, so 65.42 degrees, right? Now we have all the angles now. Now all we have to find is this side, right? We need to find this side and we will be good. Which is basically sine of 65. So sine of 65, we're looking for the opposite side of that. So we can actually use the side that was given to us to make it sure that we got, maybe if we made a mistake on this, well, we can use that one, right? To find the other side. So we can see, right? So we can actually say that sine of 40 over 20, I believe. Yep, sine of 40 over 20 equal to what? Equal to sine of 65.42 sine of 65. So okay, so here is going to be sine of 65.42 over z, right? Over actually I believe it's over c. Yes, because I did not label this. I should have labeled this. Small c. Right? So we're looking for a small c, right? So in this case, small c goes right here. Right? So again, we solve, right? And we get what? We get small c times sine of 40 is equal to 20 sine of 65.42, right? And then we want to divide by sine of 40, right? On both sides. Sine of 40 on both sides, right? And we get c is to be a small c. Look like a big c, but I think you guys get it. That technically it's supposed to be lowercase. C is equal to, when I do that math, it's equal to, oops, divided by sine of 40. Doesn't make a lot of sense. 20 sine of 65.42 divided by sine of 40, right? 28.29. So this angle should be 28.29 degrees, right? Okay, so this I'm sorry, no, that's the side. Nope. Okay, so 28.29. So basically, it's 28.29, which makes sense, right? Because all the numbers are, kind of in between 20, 30, and yeah. So basically here we can actually put 28 so we can put we can put 28.29. Right? So technically, that's how we do the law of sines, right? So, okay. So I guess next time we will do another problem with maybe using the law of cosines, right? Maybe using the law of cosine, we will do another problem. And so, or maybe we will use the law of sines again and look one of the other cases. If the sides, if all the angles inside a triangle is more than 180, so we can actually see it. In this case, we have 40 plus 74.6 plus 65.42, and very, very close to kind of fail. Yep, it's equal to 180. Pretty close. I mean, yeah, round it up. Because I rounded off, I went to 180.02, but that's kind of doesn't count because that's when we rounded up and probably made a little mistake. But it was very close to go over. Okay, so yeah, that's how we check, right? That's how we check the triangles, right? So that's it for today. I hope this video helped anybody who was taking basic trig. And thank you for watching. Remember that Jesus is the one that gives us the knowledge to understand a little bit of something every day. Thank you for watching.